Hello guys, welcome to Bugs in Code, and the problem that we are going to solve today is fixing two swap nodes of a BST. But before that, if you are new here and a person who likes stuff related to coding, then subscribe this channel so that you never miss out an update. So let's get started. The problem statement says that two of the nodes of a binary search tree are swapped. Fix or correct the BST by swapping them back. Do not change the structure of the tree. Note, it is guaranteed that the given input will form BST except two nodes that will be wrong. Okay, so there is also given one example, and let me just explain you the example. So the example is 10, 5, 8, 2, and 20. So in this tree we can see that we have two nodes swapped. So here 5 should be less than 10 and it's less than 10. Okay, so this 2 should be less than 5, so it's okay. Now this 20 should be greater than 5. Okay, but it should be less than 10 as well, but it's not less than 10. So this is something that is a wrong node. And also if we move right, then we see that this 8 should be greater than 10, but it's actually not greater than 10. So we found that 20 and 8 are the nodes which are actually swapped, and we just need to swap them back so that our tree BST become fixed BST. So this is what the problem is, that output 1 means we have written the correct tree. Okay, so now let me explain one more example. And the example is something like 2, 1, 83. After that we have here null node. Here I have 3. Here I have 47, and I have 96, and here I have 6, and here I have 4. Okay, so in this tree, here this one should be less than 2, and it's less than 2, so it's right. Now this 3 is greater than 1, so it's right, but it should be less than 2. So here this 3 is something that is creating problem. After that, this 4 is expected to be smaller than 3, but it is actually greater, so it is also creating the problem. So what we can do, even if we swap these two nodes, then still we are not going to get our correct answer, because these two nodes should be smaller than 2, but these are actually not. So what we can do is we can swap this 2 and this 4, so that here I will get a node that is smaller than 3, and here I will get a node that is greater than all of these nodes. So our answer will be something like 4, 1, 83, and 3, 2, here 47, 96, and here I have 6. Okay, so this is going to be your answer. After that, just I hope you got the clear understanding of the problem statement, and let me just move to the solution. So moving to the solution, let me draw the tree again. The tree is 2, 1, 83. After that I have n, I have 3, I have 47, and I have 96, and here I have 6, and here I have 4. Okay, so what we can do is, we know one thing, that is in order traversal of BST is always sorted. So we can make we can be benefited from these features, like if I write the in order traversal of this tree, then it is going to be 1, 4, 3, 2. After that I have 6, I have 47, I have 83, and I have 96. If you guys don't know what actually an in order traversal is, so Let me know in the comment section so that I can make a video on that as well. So this is the in-order traversal. Now in the in-order traversal we need to find those two nodes which are actually creating the problem. In this case I have 4 and 2, but how can we get these nodes? What we can do is we can have two variable for storing those two nodes, and that is going to be my first, which is initially null, and we are going to have second, which is also initially null. Now what we can do, we can traverse this array from starting, and initially I'm at, okay, so let me change the color. Initially I'm at this position and I can't do anything, so let me just move to the this position. Now here I need to check whether this value is smaller than the previous value or not. So actually this is not smaller than previous value, so I will move here. After that I found that since it is expected to be in sorted order, but here we have this value which is smaller than the previous value. So these are something which are creating the problem in the sorted order, and what we are going to do is, if our first is null, then we are going to store this 4 in the first, because this is the first node that is creating problem. So we are just going to store this 4 instead of null, and now we are not going to change this value. After that we are going to store this 3 in the node second. So we just need to find those two nodes which are actually creating the problem. So I just move further, and when I move further, then I found that this 2 is also smaller than this 3. So this is also something that should not be there, and what we are going to do is we cannot change this 4, because this 4 is something that is greater than the root value, which is 2 here. So we are going to just change this 2 with this 3. So now we have first as 4 and the second as 2. After that we are going to move further. So it is true because 6 is greater than 2. After 47 is greater than 6, 83 is greater than 47, and 96 is greater than 83. So we got our two nodes as 4 and 2, and we are just now going to swap the value. So swap 4 and 2, or I will say first and second. So this is something that I'm going to do, and after that I'm just going to return the answer. So this is the approach 1, where we are just storing the in-order traversal, and after that I'm traversing the array. So let me just code this approach, and this is the problem at Geeks for Geeks. I'm even going to provide the link in the description box. So what I can do is I can have an array list of node actually, that is going to be my list, and now I'm just going to call the in-order function that is going to have root and list. Let me just implement this function. I will have a node root and array list of type node. If my root is equal to null, then I'm going to return, else I'm going to call the function for left and list. After that I'm also going to call the function for right, and here we get our node in the in-order traversal, and I'm just going to add this node in the list. So now I have got my in-order traversal. I'm just going to have two nodes. One is the first, which is initially will be null, and second, which is also null. After that I'm going to traverse my array, the list which is stored in the in-order traversal. I'm actually starting the traversal from 1, because you can see that for this one we can't check the condition because we don't have any previous, so we need one previous to check the value. So that's why we are doing this. So now what I can do is I can just check if my smaller element is greater than the current element. So this is something which is creating problem in the sorted order, so that's why I'm going to store the value. If my first is null, then only I'm going to store the value of previous in the first. Okay, and else my second will always change whenever I found any new value. So this is my okay. So what we can do here, we can actually after that we can just now we got our first and second and we're just going to swap the values. So I will have a 10 values to the first and then okay. Now since I have got the data, so I'm just going to return the root value. So this is our approach, and since my internet is not working, so I can't run this approach. So okay, let's keep this approach and let me just move to the another approach. We are going to run this approach later. So I will call it approach 1. Now let me just explain you something that here if you notice we are using some extra space that is of any space in order to store the in order traversal in the list. So if I talk about the time complexity of this approach, so the time complexity is going to be O of n because I'm traversing all the nodes, and along with this we are going to have space complexity of O of n. Okay, so what we are going to do next is we are going to reduce this space complexity to O of log n so that we can reduce the memory consumption. So let me just move to my next approach, that is my approach 2. Just write here approach 2. Now for the same tree, let me just copy this tree from here. Okay, so we have this tree, and now what we can do is while doing the in-order traversal, I think we can keep track of my previous and then we can check the condition at the same time instead of storing the in-order traversal somewhere. So like I start traversing from this. So first of all I go to this and I make my previous as 2. I also need to keep track of two variables, first and second, which are initially null. Now when I go to this one, then after that actually I'm not going to change my previous, and initially my previous is also even null. Okay, so I move to this 2 and after that I move to this n, and since this is a null node we are going to return from here, and now we are going to print 1. So when we are at 1 our previous is null, so we are not going to check any condition, instead we are going to change our value of previous to 1. After that I will go to 3, and after that I will go to 4, and now I'm at 4 and I have the null node, so it is a leaf node, and now I'm going to check the condition because I don't have my previous as null. So I'm going to check whether my previous is smaller than the current node or not. So it's actually not smaller, so what we are going to do is we are just going to return from here, and after that I'm just going to change the value this to 4. So now my previous is something that is pointing to 4. After that now just let me move to this one again, and we are not going to check the condition for this one because we have already traversed that, and now we will go to this 2. Now at this 2 we will check whether my okay, so even at this 3 we have not printed this 3, so here also we need to check the condition whether my current node is smaller than the previous or not. So yes, it's smaller, and here we got something that is a problem, so we are going to have here 4 because our first node is null, and here we are going to have 3. After that when we come to this, so and also we change even previous as 3, so now my previous is equal to 3. After that when we come here, so what we do is we actually check whether this 2 is smaller than the previous or not. So it is, unfortunately it is smaller than the previous, which is creating a problem in the sorted order. So let me just write the sorted again: 1 4 3 2 6 47 83 and 96. So you can see here this 2 is actually also creating the problem in the sorted order. So now we just change this 3 to 2. So what we can do is, the intuition is, if we swap these two, so it is also automatically going to be in sorted order. So now we have 4 and 2 now. After that we are going to move to right, and when we move to right we check. uh, okay, so we don't check here because it is not the point where we need to print the node, and we just move to left and then move to left, and up at this condition we are at 6, and we are just going to check whether 6 is smaller than previous or not. Here our previous is also changed to 2, and now 6 is something that is greater than 2, so it's okay. Now we move to this 47 and we check 47 is smaller than 2 or not, so it is actually not smaller, so it's okay. And even you can see here it is not creating any problem in the sorted order. After that we go to 83. 83 is also greater than 2, and after, and even with this style, so we are also going to change our previous, like it became 6, it became 47, it becomes 83, and after that when we go to 96 we check the 96 is smaller than 83 or not, so actually it is not smaller, and we'll just change it to 96. And now what we got is, we got 4 and 2 as a node which are creating the problem, so we are just going to swap these nodes, and when we swap the node to, then our array becomes 1 2 3 4 6 47 83 and 96. So this is going to be our correct in order traversal for the correct BST. Now let me just implement this approach as well, but before that we are going to check our previous approach whether it's working or not. Let me just check. They may have some compilation error, but conceptually the approach is correct. Let me just run it. Okay, so it's saying that it's a bad operator type because we need to have data here. We can't compare two nodes, instead we need to compare some data, or we need to have a comparator or a criteria for comparing the values. Now we got the correct answer for the sample output. Let me just submit. Okay, so you can see that the first approach is working correctly, but it has extra space complexity. Now let me just allow to code my new approach. So I'm just going to do this approach. I'm just going to modify this with the previous code, and I will have first and second, but instead we are going to make first and second as a global variable. So I will have first and second here, and after that I will also have a previous which is equal to null. So one rule of programming is just don't initialize the global variable in the outside the class. Even we need to have a constructor, or we can even initialize them in any function. So what we can do is, now I can have my first as null and second also null and previous is null. Okay, we don't need to do this, and at last we need to swap the value first and second. Okay, so it was right. Now here we need to do something. What we can do is, we can check whether my previous is equal to null or not. So previous should not be equal to null, and or previous data should be smaller than. Okay, so need to check whether my previous data is greater than the current root data. If this is true, then we have a problem. So if my, okay, so previous data should not be greater than the current. Okay, so after that, if my first is equal to null, then first will be equal to previous, and my second will equal to root always, the current node. After that I'm going to remove this because I don't have anything like list. I'm even going to remove from here as well. Okay, so this is the approach. Let me just run it and it will work fine. Okay, I have a problem here. I forgot to remove it from here. Okay, so now it should work, I think, and let's see. Okay, so here I am having a null pointer exception. I don't know why, but I should not have any null pointer exception. Okay, so I'm not changing the previous. Each time I will make my previous as null. Whenever I do any in order traversal. So let me just now check this. It's working fine, and let me just submit it. Okay, so it's working awesome, and you see that it has submitted successfully. Now we have reduced our space complexity to O of log n. So if I write now, then I have my time complexity as O of n and space complexity as O of log n, that is the height of the tree. And now we are going to something that is even more better. We are going to remove this complexity as well, and we are going to make this approach as of one space approach. Let's see how, and it's really going to be very interesting. So just stay with me and watch the video till end. So I will call it approach 3. One thing that I hope you have heard about is something that is Morris traversal. Morris traversal, if you guys don't know about Morris traversal, so you can read any documentary or watch any video about Morris traversal. I'm even going to make a video on Morris traversal soon. So Morris traversal is something that performs the in order traversal in order traversal in of one space, and even it remove the extra stack space that is being used. So let me just show you a quick implementation or a quick idea how actually Morris traversal work. I'm not going into deep here, so let me just draw the tree. And here I have 2 1 83. I have n. Here I have, okay, so here I will have 3, here I will have 4, here I will have 47, here I will have 96, and here I will have 6. So how Morris traversal actually work? It start from these two, and it check whether its left is there or not. So if left is there, then it goes to right, and when the right of particular node is null, then it creates a thread to this. Oh, so it uses the concept of threaded threaded tree, I will say. Okay, so after that, what it do is it move here, and after that it do the same thing. It check whether left is there or not. So left is not there, so what it do is it simply prints 1. After that it go to its right. Since left is null, it go to its right, and when it is at right, then it check whether left is there or not. So left is there, and it just go to left, move to right, and create a thread here as well. After that it moves to left. When it moves to left, so it's check whether left is there or not. So left is not there, and it is simply going to print 4, and it is going to move right, and it is going to move right with the help of this thread. So now it will come to 3, and when it will come to 3, then it will simply print 3, because 3 has no any right element, and it will move here actually. And when it see that there is a link, so it removes this link. Now this link is no more there. After that it moves to its right here too, and when we come to 2, then what we do is we check whether the left of 2 is there or not. So yes, left of 2 is there, and when it just move to 3, and it sees that there is already link present, so it makes this link as null and print 2. After that it moves to right, and it do the same for right. Like it will go to right to check whether left is there or not. It will create a thread. After that it will move to left. From this left it will create one more thread here, and it will move to left again. Then it will print 6. It will go to this 47 with the help of thread, and after that it removes this thread. So now we have 47, and after that it moves to 83 and removes this thread as well. So 83 is there, and similarly 96 is also there. So this is about how actually in order traversal with the merged in of one space works, and we are just going to perform the same task in this in order traversal. So let me just implement this code as this approach as well, and it is really going to be fun. So I will have a node that is current, which is initially equal to root. While my current is not equal to null, what I'm going to do is I'm going to check whether I have my left current is null or not. So if it is not null, I'm going to do something, and if it is null, then you saw that when it was null, we are just going to print our stuff here, and then we are going to move to right. Okay, so and here we are just going to have a time variable that is storing left, and while my temp dot right is not equal to null, and even temp dot right is not equal to the current, then I'm going to move my temp to right. After that I check if my temp node is doesn't have any right, then we are going to do something, and if it has a right, so we are going to print the node, and along with this we are going to make the right null as well. So will be equal to null here, and after that what we can do is we will move our current to right. Here we just need to make our temp dot right as current, and we will move current to left. Now we are at this point where we need to print our node. So what I'm going to do is I'm going to check whether my previous is equal to null. So if my previous is not equal to null, and the data of previous is smaller than current data, then this is a matter of concern. After that I'm going to change my previous to current, and the same thing. Okay, so here if my first is equal to null, then my first is going to be equal to previous, and my second is always going to be equal to current, and we are just going to have the same thing here as well. Now, but where is our previous first and second node? So we are just going to create them, and second is all. Now at last we just need to set the values. So I have a temp variable that is storing the data of first, and then okay, with temp. At last we will return our root. So this is the approach. Let me see whether it's working or not. I think it should work. So there may be compilation error. Okay, so it's not actually working. Let me see why it's not working. Here I need to print my data. Okay, no problem here. Let me first check whether my code is printing the correct in order traversal or not. This is something that is very important. So I'm going to write in the data of current here and here as well. So it's a kind of debugging technique that helps to check whether code is working. So here you can see the correct in order traversal is being printed. So there's no problem with this in order traversal. After that we are going to check, okay, each time we are going to change our previous to the current, there is no problem, and previous is not equal to none. And if my data of previous is actually greater, I think. So this is something that is a problem. So this should be the condition. Let me just check it. Let's see, works or not. So it's working for example test case, and let me just submit this solution. Okay, so it's working, and these are the approaches to solve the problem. Here I have explained three approaches, and I hope you like the solution that I have explained. So if you like the video, then you can hit the like button, and this is all for now. Thank you and stay tuned.